So this is problem number 7, I think, which is like problem number 7 in the video. I took liberties and did graph it, although you wouldn't have had to graph it. So the idea is that if you take the integral of a derivative, you're going to get just that function value, right? And so what we're going to do is accumulate the values. So they had to give you the starting point, and you're going to see a little bit more later on when we do the indefinite integral about adding this plus c, and you'll maybe it'll come together a little bit better for you. But for right now, just understand that we're saying the value of the function at our starting point is 12. So we're going to take 12, and then we're going to add integral of the derivative, the integral of the derivative, and that's going to accumulate. So we're going to go and accumulate the values from negative pi, because that was our starting point, up to where we want to go, which is 3 pi over 2. So bear with me here. 3 pi over 2 of the cosine of x dx. All right, so what you learned in this lesson is how to take the antiderivative. And the antiderivative is what could you take the derivative of to get cosine? And the answer is sine. If I take the derivative of sine, I get cosine. So the antiderivative is sine, and we're using the fundamental theorem of calculus, part 2. And we're going to take that value, evaluate that from 3 pi over 2 to negative pi. Okay. So let me see here. So I have 12. Can't find my pen. So I have 12 plus, and then I'm going to put a bracket here. The sine of 3 pi over 2 minus the sine of negative pi. Okay, so if we just think of a quick unit circle, on the unit circle, negative pi would be over here, right? That would be negative pi. And positive 3 pi over 2 would start here, and it would be right down here, right? So, all right, so we have to figure out what the sine or the y value at 3 pi over 2 is, and that is negative 1. And then the y value at negative pi is 0. So all I have to do is add 12 to negative 1, and I'm going to get 11. And that is the answer for that one. Okay? So just once again, the way you set these up is that you take the integral of what they give you as the derivative. And we're looking for how much you're going to accumulate. Oops, I shouldn't have put the prime right there. So the derivative of this is the integral. And so we're starting off at 12, and we're accumulating all of the with a value of 12. And so you can see you have some negative area, here, and then you're adding a whole bunch of positive area. And then you're subtracting some more area. So all the way up to here. So really, you can see you're really only having a net, loss of whatever this area is here, because these two areas would cancel each other out. That would give you 0. Anyway, just by looking at it. But here's the analytical way to do that. Just like that. All right. The ones like number 8 And number 10 and number 12, you just set those up on the graphing calculator. So for example, if we look at let's say number 8, okay, we pull up the graphing calculator. Let me go down here. Okay, so number 8 says that f prime of x is equal to the sine of 3x. And we have to know an initial or know a value. Sine of x plus e to the x. And then we know that f of 1 is equal to 0.751. And we need to find f of 4. Okay, so you know you're going to have the starting amount of 0.751. And then what you want to do is you want to take the integral of this derivative, which is going to be just f, of the sine of 3x plus e to the x. Now, actually, well, I guess not quite yet. I was going to say you know how to find the integral of that, but you don't. So we have to use, this one says it's calculator active. All right, so we'll pull up the graphing calculator. And sine of 3x plus e to the x. Pull this down a little bit. Clear. Sine of 3x, close parentheses, plus second e to the x. All right, now, I guess the way I do these, let's see, we're going to go from where to where, all the way up to 4. So for my window, I'm going to go from, I'll just go from 0 to 4. And let's see, I'll just graph it. Oop, I guess I didn't graph it quite big enough. Oops. All right, so then if you, the way I was showing you guys that you can do this is just by going into second calc trace and down here to number 7, and it says integral, and I want to integrate that from 1 to 4. So it says lower limit 1, upper limit 4, enter. And so we're accumulating 51.2685. 2685. Yeah. And I should have put that here on this one. Sorry. That. So this was going from 1 to 4. And it was 26 point. Darn it. 51.26. 2685. So I'd have 0.751 plus 51.2685, and then adding those up back here with my calculator. If I go second quit and clear, second answer plus 0.751. 52.0195. So You can round that how you want, 52.0195, or if you round it up, it'd be 120. So 52.120 would be fine. All right. And if you use the other method, I think math number 8 or something like that, whatever the Mr. Bean taught you guys how to do. Let's see if we can just review that a little bit. So second quit, clear. And I think I still have that in. So we go math and go down to number 9, I guess it was, not number 8. And we're going from 1, whoops, darn it. There, where you get that, and then you'd add that to the 0.751. There's your answer that way. I kind of like the graph, but that's just me.